Hi everyone, this is Mrs. J, and today we're going to be talking about applications of quadratic functions, which is essentially just quadratic function word problems. But first, I have a warm-up for you guys to try, so please pause the video. All right, go ahead and check your work here. So for this first one, once I set my equation equaled 0 and I divided both sides by 4, I noticed this was factorable. So you could also do quadratic formula, but I think this is the easiest way to do it. And then for part B, I set my equation equal to 0. This is not factorable, so I used the quadratic formula and I got two imaginary solutions. Make sure your answer is fully simplified. All right, so today we're going to be doing word problems that involve quadratic equations. So for these, I think the trickiest thing is identifying what they're asking us to find. What part of our quadratic equation are we trying to find? So let's look at this first example. Jason jumped off a cliff into the ocean of Acapulco while vacationing with some friends. His height as a function of time can be modeled with this function right here. So you see his height is modeled with a quadratic function where t is the time in seconds and h is the height in feet above sea level. So in this case, our x-axis represents the amount of time that has gone by. So this first one says, how long did it take for Jason to reach his maximum height? So the first thing we need to do is identify what are they asking us to find. If you ever see the word maximum or minimum, we know that this is going to involve the vertex. And since it's asked how long, we know that time is in reference to our x-axis or our input. So they're asking us to find the x value of the vertex. So once you know what you're trying to find, then you should already know how to do that. We can just use our little formula that x equals negative b over 2a when our equation is in that standard form. So we could say x equals negative 16 over 2 times negative 16. So x equals 1/2. And then we'll want to make sure we answer this with units. So it would take him half a second to reach his maximum height. Then if you look at part B, it asks what was the highest point that Jason reached. So since we're doing that highest point, again, that implies maximum, but this time they actually want the maximum height, and that would be represented by the y-axis. So here they want the y value of the vertex, which is essentially means that we're finding h of 1/2. So negative 16 times 1/2 squared plus 16 times 1/2 plus 480. And we should get 484, and then we'll just want to make sure we have our answers with units. So 484 feet, which is the units of our y-axis. The next thing they ask is, what was Jason's initial height? So when you see the word initial, that means the starting point. So when they ask for the initial height, they want the height when t equals 0. And if t is equal to 0, essentially what they're asking for is the y-intercept. And we know that we can identify that just by simply plugging in 0 to our function. And if you look here, if this turns to 0 and this turns to 0, we're just left with 480. It's just always going to be that c value. So 480 feet is his initial height. So I guess that's how high that cliff was. And then since his maximum height was 484, you can see that he actually jumped up, and then after half a second, he reached his highest point, then he went down. So for part D, they're asking us, how long does it take for Jason to hit the water? So they are asking how long. So we do want an x value, but they're asking for Jason to hit the water. If Jason is hitting the water, that means that your y value or your h value is 0. So again, the height is 0 when you hit the water. And if you're finding when y equals 0, they're asking us to find the x-intercept. And if there's more than one, we would look at both. And of course, Any negative x-intercepts won't work for this problem because there's no such thing as negative seconds. So really we want positive x-intercepts. So as long as you can identify, okay, if Jason is hitting the water, that means that the height is 0, and we know that when y is 0, that's an x-intercept. So let's go back to our original equation and set our y value equal to 0. I'll say t squared, and then we have plus 16t plus 480. So from here, to simplify this equation, I'm actually going to divide both sides by negative 16. So we get 0 equals t squared minus t minus 30. And then from here, we can actually solve this by factoring. We get t plus 5 times t minus 6 equals 0. So we get t equals negative 5 and positive 6. So again, negative 5 doesn't make sense for the context of this problem because t represents time. So we'll just take that positive x-intercept, and that means that it would take him 6 seconds to hit the water. All right, and moving on to this last one, how high is Jason after 2 seconds? They're just asking us to find the height when t equals 2. So they're just asking us to find h of 2. So all we need to do is go in and substitute t with 2. And we should get 448. So we have 448 feet. And there you go. So you can see that with these types of problems, there's different parts of your function that you might be asked to find. Maybe you're finding the x or y value of the vertex. For those problems, you're looking for that keyword of max or min. Maybe they're asking you to find a y-intercept, which will usually be like an initial amount. Maybe they're asking you to find some type of x-intercept, which is maybe when, the height is equal to 0. And then they also just might be asking you to find a random value, substitute a value into your function and see what that height is. So I think once you can identify what part of the function you're looking for, finding it should be the easy part. It's either just solving the equation or finding the vertex or finding a y-intercept. But again, just make sure you're identifying the correct part. So now that we've done one of these problems by hand, we're also going to learn how to do these problems with our graphing calculator. So we're still going to have to identify what part of the function we're going to find, but this time we're going to use our graphing calculator to actually find it. So a few skills we are going to need to know how to do. First, we're going to need to know how to just graph a function. So hopefully we know to look for that y equals button, and then we will want to be able to type in our function. And then, of course, from there, we're going to want to be able to see our function. So if you ever type in your function and then you hit graph, so after you type it in, you're going to hit the graph button. And sometimes you'll do that and you won't see anything. And the most common reason why you won't see anything is because your window is not set. So then you're going to need to adjust your window appropriately. So there's a button along the top that says window that you'll look for. And then you're going to set the x min and x max, and then the y min and the y max appropriately. You should also be able to find zeros of a function. So after you've graphed your function, you're not just going to trace over it and estimate. It can actually find the zeros with a special feature. So if you hit the second button and then the button that says trace, that brings you to a screen that's called calculate. And there's lots of different options from there. You're going to use second trace a lot. So within calculate, one of the options is to find the zero. So you're actually going to use option 2 for this one, which is 0. So you could scroll down and hit enter, or just hit the number 2. And then there's going to be a process it goes through. It's going to ask you to identify a point to the left of your 0 and a point to the right of your 0. And then you'll have to hit enter a third time. But we'll kind of talk about that process as we do some of these problems. Another thing you might want to do is you might want to evaluate a function. So just plug in an x value. And for us to do that, we can go back to our second trace, which would bring us to calculate. And this one, we would want to use option 1, which is just value. And then from here, it would allow you to plug in any x value you want, and then it will tell you what the y value is. One thing to note is we can plug in any x value. However, it doesn't work in the opposite way. We can't choose the y value and get an x value. So we would have a different approach for that. But just note, this allows you to evaluate your function at any x value. And then another super useful thing that we've talked about in a previous lesson is finding a max or min. So again, we go to our trusty second trace. And then from there, we will either select option 3 for minimum, depending on the context of the problem and what they're asking for, or option 4 for maximum. Now there's kind of this interesting process. It will ask you to locate a left bound and a right bound. So you kind of scroll your cursor over until you're clearly to the left of your vertex. You hit enter. Scroll it until you're clearly to the right. You hit enter. And then you will have to hit enter again a third time before you get that max or min value. A very similar process to finding that 0. All right, so let's try another example together. And this one we're going to use our graphing calculator to help us answer the questions. So this says a small independent motion picture company determines the profit for producing a certain number of DVD copies of a recent release. And that function is modeled by this right here. Where P is the profit in thousands of dollars. That's going to be important when we give our final answer. And N is the number of DVDs produced in thousands of units. So how many DVDs should the company produce to maximize the profit? So as soon as I see that word maximize, I'm thinking vertex. The max or min will always occur at the vertex. However, if they're asking how many DVDs, that's going to be that number of units. So that is going to be the x value of the vertex. So we can use our graphing calculator to find this. We're going to graph it, and then we're going to find the maximum. And that will actually give us both the x and the y value of our vertex. So the next thing we're going to need to do is type in our equation to y equals, and then we're going to need to hit the graph button, and you'll see we'll also need to adjust our window to get a better picture of our graph. So let me input a couple pictures of what my calculator looks like. All right, so let's take a look. So if you hit that y equals button, it allows you to type in your function, and we're just going to use x instead of n. And then if you went straight to graph, you would see that most of your graph is not included in your window. So this is how I set my window, and this is the graph it gave me. And again, that window button is right here, and then you go back to graph. So a few things to note, because it's a real-life application, I'm really only focusing on the positive x and y axis, so this upper quadrant. But you do want to make sure you have like a nice picture of any intercepts that are positive, and you want to make sure within your window you can see your maximum or minimum value. So your window doesn't need to be exactly the same as mine, but it should be similar. Another thing, if you're ever adjusting your window and you see that it won't let you graph, it says you have an error. 2 common mistakes. One is the negative. There actually is a negative button on your calculator. It's right under the 3 button. It is not interchangeable with the minus button. If you are doing -3 or -2, you need to use the negative button, or else your calculator will say error. Also, if you ever make a mistake with your min or max, if your minimum value is not actually smaller than your maximum value, it will say that there is an error. So those are 2 things to look for if it's not showing you your graph and it's indicating an error. So now that you have a nice picture of your graph, we do need to find the x value of the vertex. So we are going to go to second trace. Let me show you a picture of what this will look like. Okay, so first, when you hit second trace, and then you hit option 4 for a maximum, first it will ask you for a left bound. So you kind of scroll, you go left or right on your cursor. I moved my cursor to right about here, and then I hit enter, and you'll see that it kind of adds in this marker for a left boundary. So it has to just be to the left of your vertex somewhere. Doesn't need to be that close to your vertex. And then it will ask for a right bound. So you kind of scroll your cursor somewhere that's clearly to the right of your max, and you hit enter again, and it will add in this second boundary. And then you'll see here it asks guess. So once you have your boundary set, you will have to click enter a third time, and then it will estimate that maximum value. So here you can see it gives us the x and y value of our vertex, and when it says 84.99999, remember it's technically an estimate, but this is really just 85. We can say it's close enough to 85, and here's the y value of our vertex. So now that we know those values, we can answer the question. So the first one, they ask how many DVDs should they produce. So it's the x value of your vertex, which is 85, but remember our units are in thousands of units, so that means that they should produce 85,000 DVDs. And then if you look at the second question, what is the maximum profit? Well, again, maximum implies vertex, and the profit in this case is represented by the y-axis. So this one, they want the y value of the vertex, which we saw was 128.5. But remember, those units are also in thousands. So then when we give our final answer, we would want to say $128,500. And make sure you have that dollar sign out front. You should all know how to indicate the unit for dollars. Okay, and now let's look at this last question. It says, over what interval of DVD production will the company be profitable? So we have to kind of figure out what are they asking for us here. So if a company is profitable, that means that the profit is greater than 0, right? That you're making some profit. Any profit greater than 0, you are considered to be profitable. So they're essentially asking us to find our zeros. They want to know, when do you start being profitable and when do you end being profitable? So over this entire region, since we're above the x-axis, the company is profitable. So since they're asking for the interval of DVD production, we're going to actually find those x values. So here they actually want the x-intercepts, or the zeros. It's just another way of saying zeros. So I'm going to show you a picture of what this looks like. Okay, so to get to this feature, you do the second trace, and that leads you to calculate, and it's going to be option 2. So first it will ask you for a left bound, so you need to scroll to the left of your 0 and hit enter, and then scroll to the right of your 0, so somewhere around here, hit enter, and then you'll have to hit enter a third time for it to guess what that 0 is. Same process. Then you'll have to scroll way over to your other side. You'll hit somewhere to the left of your x-intercept, scroll to the right of it, hit enter, and then hit enter a third time. Now over here you'll see that the y value, it looks a little weird. So this is actually how we show scientific notation. This means -1 times 10 to the power of -11. So again, it's an estimate. This is actually an incredibly small number. It's super, super, super close to 0. And again, we can essentially just say that this is 0. So I know it doesn't say y equals 0, but it's so incredibly close, it still is an x-intercept. So those are the intervals of DVD production that our company is still profitable. So remember, these numbers are in thousands. So I'm going to round a little bit here. I'll just say that it's profitable from 4,840 to 165,160 DVDs. So I rounded a little bit for those. And again, I took my x-intercepts and I converted them into thousands to match the units that were given in the problem. So again, you could see that we still need to determine what part of the function they're asking us to find, but then instead of having to do that by hand, we're going to have our graphing calculator find that vertex and find those x-intercepts for us. All right, we're going to try another one together. So here we have a water balloon is catapulted into the air so that its height in meters after t seconds is modeled with this function. So first you're going to need to graph this function. So you're going to need to go back and delete the other one, graph this one, and readjust your window. So you should end up with something that looks like this. Again, you're going to need to do a pretty big adjustment from the last window that we used. And then if they want the height after 1 second, so how high is the balloon after 1 second, they're essentially asking us to find h of 1. They want us to evaluate the function. So if you go to second trace, so if you go back to calculate, option 1 is called value, and then it allows you to type in any x value you want. So I typed in x equals 1, and it told me the y value. Now, of course, this is something where you could have just substituted and used your calculator to evaluate it in that way, but this might save you a little bit of time. Since we found h of 1, the answer is 24.5, and we want to make sure we're using the right unit, so it's meters. The next question they ask is, what is the maximum height reached by the balloon? So maximum implies vertex, height implies y value, so we're finding the y value of the vertex, which we talked about how to do in that last example, second trace, and then you go to maximum, and you go to the left and right. And then for this one, we can round, let's say 39.6 meters. So again, we're looking for that y value of our vertex. And then it asks how or when will the balloon hit the ground? So if it's hitting the ground, that means that the y value is 0, the height is 0. And since they're asking when, they want the x value. So here they're asking again for the x-intercept or intercepts. And of course, we only want the positive one because you can't have negative seconds. So if you look at the picture of your graph, this x-intercept is actually a little bit negative. So really the only one we want is this one. So you can go through that process and find that 0, and that will happen at about 5.6 seconds. Now, for this last part, this one's a little bit trickier. They want us to know, they're asking for how long, so that's going to be an interval of x, is the balloon 30 meters or higher? So that's the y value, when the y value is 30 or higher. So we kind of have two options here. Remember, we can't plug in a y value and get an x value, but what we can do, one option, is we can actually graph the line y equals 30, and then we're actually going to find, the point of intersection between those two graphs. So first you're going to need to go back to y equals, type in just 30 for under y2, and then hit graph. So you should get something that looks like this. So notice I didn't delete that first function. I still want that quadratic here. I just graphed the line y equals 30. And then I want to describe this interval, so this length of time, because this is the time for which the water balloon is 30 meters or higher. So I want to now figure out what this x value is and what this x value is, so I can find that interval of time. So for this, we are going to need to find the point of intersection. So you go back for this one. We didn't write this in on that previous slide, but you go to second trace again. So we go to calculate. And then if you look down at option 5 says intersect. So that's the, you're either going to hit 5 or you're going to scroll down and hit enter. So now when you do that, your calculator is going to ask you, it's first going to say first curve. So you're actually going to scroll your cursor until you find your cursor, and you're going to see which curve it's on. For me, it started on the quadratic, and I kind of scrolled it over until I was close to this first point of intersection. I scrolled it somewhere around here, and I hit enter. And then you'll see that the cursor jumps over to the red graph here, and then it asks second curve, and you're confirming that this is the second curve, and you hit enter, and then it asks you again to guess. So you have to hit enter a third time, and then you should see it give you a point of intersection that looks like this. So here it gives you the x and y value of the point of intersection. And then you're going to go through that same process again and find that for that second point of intersection. So that should look something like this. So I can see that it's from, I'm just going to round from about x equals 1.4. That's the time when it reaches 30 feet, and then it crosses back over at about x equals, we'll just say 4.2. Now, if the question is for how long is the balloon 30 meters or higher, we would actually want to find the length of that interval. So we'd actually want to do 4.2 minus 1.4, and that would give us an interval length of about 2.8 seconds. So this is definitely requires a little bit more critical thinking to allow us to solve this problem. Now, alternatively, another way we could do this is if we want to say, okay, for how long is it 30 meters or higher? We could actually plug in 30 for y in our function. So we can go back and substitute it here. So instead of y, I'm going to put 30, and then here's our original function, negative 4.9 t squared plus 27t plus 2.4. And then I would set my equation equal to 0. Minus 27.6, and then this is what I would graph. I would actually have to go back in and delete my first equation and type in this equation, and then from there you would find the zeros, because you want to know when this function is equal to 0. And those zeros would be about 1.4 and 4.2, so you get the same x values, and then you'd find the difference between those numbers. So again, you could either graph the line y equals 0 and find those points of intersection using your graphing calculator, or you could replace the height with 0, set the equation equal to 0, graph this new function, and find those x-intercepts, or find the zeros using your graphing calculator. And there you have it. All right, so now we're going to look at a problem where we're actually going to have to create our own quadratic function to model this scenario. So this is a rectangular field, will be fenced on all 4 sides. There will also be a line of fence across the field parallel to the shorter side. So let's draw a picture of what this would look like. So just give yourself a rectangular field. And then it does say here that there's an additional line of fence across the field parallel to the shorter side. So I can see that these are my shorter sides, so it should be parallel to that side. It doesn't say where in the field. It doesn't need to be in the exact middle, just somewhere in between. It says if 900 meters of fencing are available, what dimensions of the field will produce the maximum area? So we want to maximize the area and then figure out what is that maximum area. So we're going to need to find a way to create a function that models the area of this rectangle. So first, we need to pick something and define it as our variable. So let's say I define this as x. I'm always going to define it in words as well. So I'm going to say the length in meters of the shorter side. So that means that this is also x and this is also x. Now, if I want to define what this side length is, I'm going to have to use an additional piece of information. I know that I have 900 meters of fencing to work with. So you can see that if I'm laying down these 3 strips, I've used 3x of fence. So what I have left over is 900 minus 3x, but since I have to split that up over 2 sides, I'm going to divide it by 2. So this expression represents the length of the longer side. And again, it's because I started with 900 meters of fencing. I subtracted away 3x because I have 3 of these shorter sides. And then that remaining fence, I have to split up over 2 longer sides. So again, that represents this dimension of the field. And then, of course, we know that the area of a rectangle is simply length times width. So it's going to be x times 900 minus 3x all over 2. So this is a quadratic equation. So here we have x equals negative 3 over 2x squared plus 450x. So I just simplified this equation a little bit. And so now this is my quadratic model. And so they ask us what is the maximum area and what dimensions will produce that maximum area. So since I see the word max, I am going to use my calculator to help us find our vertex. So again, type in this function, use your calculator to find the vertex. And we get a vertex of 150 and then 33,750. So you'll see when you graph this, you're actually going to need to expand your window pretty significantly. I'd also say if you're ever having a really hard time getting this function in your window, please don't forget that you can do this the old-fashioned way. You could use negative b over 2a to help you find this vertex. So if it's taking too long on your graphing calculator, just go ahead and see if you can do it by hand. But I was able to find this in my graphing calculator. So if they want to know what the maximum area is, that would be the y value. So the maximum area would be 33,750, and then we'll say meters squared, or square meters, because area, remember, the units needs to be squared. And then if they want the what dimensions produce that, well, we know that this is the optimal x value. So we know that that width should be 150 meters. And then for that length, if you take 150 and you substitute it right here, so you do 900 minus 3 times 150 all over 2, we get a length of 225 meters. So make sure you're giving both dimensions. It doesn't really matter which one you call the length and which ones you call the width, as long as you have the 2 dimensions here. So again, there are going to be some cases where you have to use the given information to help you to create your own quadratic function, and then from there determine what part of the function are they asking me to find, and then how do I find it. All right, let's try one more together. So this says tickets to a school dance cost $5 and the projected attendance is 250 people when it's that price. For every 10-cent decrease in ticket price, the dance committee projects that the attendance will increase by 10. So we want to determine the dance committee's greatest possible revenue and how much should the dance company charge per ticket to obtain that revenue. So first we need to understand what revenue is. Revenue is just how much money do you take in. So this doesn't have anything to do with costs or anything like that. It's essentially price per item times the number of items you sell. So the price per ticket times the number of tickets. So we want to find a way to model revenue. And for this, I think the easiest way to model these problems is by setting your variable x equal to the number of price drops. So how many times should we decrease the price by 10 cents to hit that sweet spot? So of course, if we decrease the price by a little bit, we gain more ticket sales. However, we don't want to decrease the price too much because at a certain point we're going to end up losing money. So we want to decrease it enough to get enough more people to buy, but not to the point where we start losing money. So if we want to model revenue in terms of X, first I'm going to model the price. So the initial price was 5, and then I'm going to drop my price by 0.10 times X, 10 cents times however many times I decide to drop the price. And then to revenue the number sold, well, the initial projection was 250 people, but I know that that will increase by 10 every time I drop the price by 10 cents. So for each price drop, I increase the number sold by 10. So when you go to plug this into your calculator, you don't even need to multiply this out. You can type this in factored form. And you will see that you need to really zoom out. You'll need to definitely play with the window a little bit. But again, you could type it into your Y1 into your calculator exactly as you see it here. You do not need to FOIL it out. You don't need to combine like terms or anything like that. So once you have it in your calculator, it's asking you how much should they charge per ticket and what is that maximum revenue. So since you see the word maximum, they want the vertex, and they do actually want the X and the Y value because X will help you determine the price, but they also want to know what the revenue is, which would be the Y value of the vertex. So if you find the vertex using your calculator, you get that it's 12.5 and then 1,406.25. So remember that the Y value of the vertex, this actually is revenue. But the X value, remember, is the number of price drops. So this does represent my maximum revenue, but this is the number of price drops to maximize that revenue. But I want to know what the actual price should be set out. So first, let's record our maximum revenue is $1,406.25. Now, if I'm doing 12.5 price drops, I would take my initial price, which is $5, and then I would subtract it by 10 cents, and I would do that 12.5 times. So again, this is my initial price. This is the price drop, and this is the optimal number of price drops. And we end up with 3.75. So the optimal price, or the price they should set the tickets to be, would be $3.75. So just be careful with this one. In this case, the way we define X was as the number of price drops. So remember, X doesn't represent the price. It represents how many times we should decrease the price by 10 cents. So just be careful when you're going to give your final answer. If they ask how much should they charge per ticket, you have to do a little extra critical thinking to give the correct final answer. All right, I have one last problem for you to try on your own. So again, please pause the video and hit play when you're ready to check. All right, go ahead and check your work here. So again, I'm defining X as the number of $1 price increases. So as they increase the price, yes, they are losing subscribers, but they're gaining revenue because the price is higher, so they have to find that sweet spot. So we can define the price as 10 plus 1x, the number of price increases times that price increase. And then we could define the number of subscribers as 80 minus 5x. So 80 million was the initial, and they lose 5 million for every one of those price increases. So again, you could type it in exactly as it is here. I would keep this as in millions, so don't use 80 million, just use 80. And just understand that your answer is in millions. And then since we're working with a maximum, we'll want to find that vertex. So the Y value does represent the maximum vertex. Remember, the X value represents the optimal number of price increases. There we go. So we should increase the price 3 times. So if the original price was 10 and we increase it 3 times, the optimal price is $13 per month, and then that maximum revenue would be $845 million. All right, that is all for today's video. Thank you so much for watching.